All right, welcome back everyone. So last time we talked all about topographic maps. We found how to find out the maximum height of a hill, stream flow, index contour lines, the legend of a map. But today's focus is a little more technically oriented. We're going to learn how to draw a topographic profile, which is really like a side view of a feature on a topographic map. Now they're useful for a lot of reasons. I can think of one personal reason. Back when I used to race bicycles, it was always nice to know what a road course or a mountain course looked like as far as the side view goes. Because when you look down on a topographic map, you can see the contour lines, and that's great. But you could also see on a side view exactly how long and how steep the hills were, and that's useful for a lot of reasons, especially if you're a bad hill climber like I was. All right, so let's take a look at this map, which shows a landform. The side view is down here. And these are just lines showing elevations. These are like our contour lines. And here is a top view, a topographic view, that this was derived from. And so these are the contour lines you'd see on a topographic or contour map. And all these lines were used to create this side view. So that's what you're going to learn how to do today. It involves scrap paper. It involves a pencil, making lots of little marks, and carefully plotting. But it is kind of fun. So how are profiles made? Well, first we need to mark elevations on scrap paper, and then we're going to transfer these to some sort of graph. So this example shows a topographic map in Colorado, Cottonwood, Colorado, and you can see the scrap paper is placed between 2 points, point A and point B. And there's the scrap paper along that line. Now that line crosses over a whole bunch of contour lines, which we could determine the numbers for. Let's say those are all the marks where the contour line touched the scrap paper. We could also write the elevations of those lines on the piece of scrap paper. For instance, this 500 would be right there. I like to write them this way because it tends to fit better. There'd be a 520 for that line, 540, 560, 580. So you get the idea. This would be another 500 over here. This looks like a 520, this line. 540 right here. 560, 580. This must be 600. Okay, once you get all that done, then you're going to take that scrap paper and move it over here. And remember, all these little numbers would transfer with it. For instance, this 500 line and this 500 line. And then you just go straight above it and you'd plot the mark. Now sometimes they want you to plot X's, sometimes dots. It all depends on the directions. And then when you get all your dots in, eventually you're going to connect them all. You're going to end up, your dots would all be along here, with a nice smooth curve showing the side view of the topographic landform over here. So this is the profile, side view, and this is the topo map, top view. Now this is all great and everything, but I think there's probably a better lesson on this than hearing me talk. So let's skip over and check out this little YouTube video, if I can get there. There we go. Today we're going to learn how to draw a topographic profile. A topographic profile is a side view of a topographic landform. Just think of it as a side view of a top view. Why do we bother drawing profiles? Because profiles show us the steepness of the terrain between 2 points on a map. That's why. This is useful for all kinds of stuff, from construction cut and fill projects to hikers seeking the most gentle route up a mountain. To draw a profile, first you need a topographic map. Here's a topo map of Fort Plain, New York. Notice the rivers, roads, houses, but if you look real close, you'll see the contour lines showing points of equal elevations. This is what we'll need to complete our profile.
So to start, let's examine the following map showing contour lines. First, place a sheet of scrap paper between two endpoints of your profile. Mark each contour line and its elevation onto your strip of paper. If done correctly, you should have a strip of paper with a bunch of tick marks and elevations below each one. Next, place your strip of paper along the bottom of your graph paper, making sure your y-axis is properly set up to handle your smallest and largest elevations. Notice mine goes from 4,000 to 8,000 and easily fits the data. Next, transfer your elevation data onto the graph by marking a point at the correct elevation directly above each tick mark. Connect your points, being careful to crest the hilltops and dip below the valleys. To summarize what we learned, first place a piece of scrap paper on your topo map and line it up from the beginning to the end of your profile. Then mark off the location and elevation of each contour line touching your scrap paper. Line your scrap paper up at the bottom of your graph paper and transfer the elevation points until all contour lines are accounted for. Connect your points. Making profiles is both easy and fun. And be sure to practice this skill because it will be on your test.
Well, that's it, guys. Hopefully you learned about profiles. Now we're going to go practice.